day, class. So in this lecture, we will discuss about inductance. So last time we discussed magnetic flux and induced EMF. So now let's proceed to inductance. So here, suppose you have two loops of wire. So two loops of wire. Tas at rest sila. Pero there is or a current I1 passes through the first wire. So, bale, it will produce a magnetic field B1. So, here, it will produce, di ba, current carrying wire siya. So, current carrying wires will produce magnetic fields. So, in this case, B1. So, ang itsura niyan, meron kang wire 1 dito na may tumatakbong I1 sa kanya. So, this is your loop 1. Tapos, meron ka ding loop dito sa taas. Let's call this loop 2. Due to wire 1, magpo-produce yan ng magnetic field, di ba? So, ganyan yung itsura niyan. Therefore, merong papasok na magnetic fields dun sa loob ng loop 2. Now, let us recall, ano ba yung magnetic field na pinoproduce ng wire 1? Let's recall the Biot-Savart law. So, yung Biot-Savart law, so B1, that is just mu naught over 4 pi I1 tapos closed loop integral ng dl1 cross r hat over r squared. So, ito yung medyo mahirap i-calculate, di ba? Pero, i-simplify natin siya. This is a constant, itong mu naught over 4 pi. Tapos, yung definite integral na to, constant din yan. Bale, ang ating B1 can be written as, let's say, some value. Some value multiplied by I1. So, proportional siya sa I1. And therefore, the flux through loop 2, B dot dA yan. So, this is given by phi B2. Yan ay area integral ng B1 dotted with dA2. So, bale, ito ay I1 integral ng some value. Diba I1 constant lang yan? So, some value dotted with dA2. So, ayan. Tas class again, ito ay, ang definite integral na to, tawagin na naman nating some value ulit. Kasi 'di ba, ang definite integral function lang naman yung nilalabas niyan. So let's say this is some value again. M21. So bakit M21? So mamaya. So at ng ating magnetic flux, phi B2 can be written as M21 times I1. So phi B2 equals M21 I1, where M21 is called the mutual inductance. So this is the mutual inductance of the two loops. Ingay ng mga aso dito sa amin. Of the two loops. Ayan. And isulat ko lang that the mutual inductance, so yung mutual inductance natin, may value yan. Has a value of, di ba? Itong una, yung some value na una, isang integral. Tapos itong isang value na pangalawa, in-integrate mo ulit. So, bali double integral yung ating M21. So, ang M21 natin, mu naught over 4 pi double integral ng dl1 dotted with dl2 over script r. So, yan lang siya, yung mutual inductance natin. So, let's note that M21 is purely a geometrical quantity. Hindi siya dependent sa current, hindi siya dependent sa charges, depende lang siya sa geometry ng wires natin, yung DL1 and DL2. And also, M21 equals M12. Kasi 'di ba, pag pinagpalit mo yung 1 and 2, so magiging M12 yan ay DL2. So ito DL2 dotted with DL1. Pareho lang yan sa DL1 dotted with DL2. So M21 equals M12. And to simplify things, since M21 equals M12, let's call it M. So let's call it some value M kasi pareho lang naman yan. Now, let's say, suppose the current in wire 1. So the current in wire 1 is changing in time. So kunwari, hindi na siya constant, nagbabago na siya. So the induced EMF, syempre nagbabago yung current sa wire 1, magbabago din yung magnetic field. And therefore, magbabago yung magnetic flux. So the induced EMF, syempre kung meron kang changing magnetic flux, meron kang induced EMF. So the induced EMF in wire 2, that is given by, let's call that E2. So negative d phi B2 over dt. Diba? Negative d dt ng magnetic flux. Ano ba yung phi B2? Diba M2, MI1. So negative d dt ng MI1. And since M is some constant lang yan na hindi dependent sa time, kasi diba purely geometric quantity siya. So this is equal to negative M di1 over dt. Tapos take note class. So note ulit natin that the changing current. So the changing current in wire 1 not only induces an EMF in wire 2, but it also induces an EMF in itself. So it also induces an EMF in itself. Kasi class, di ba? Ito. Meron yung pinoproduce na magnetic field. Yung magnetic field na yun, tumatagos din sa loop 1. Siyempre, pag ganyan yan. Di ba? Tapos, nagbabago yun. Nagbabago yung magnetic field na yun. Di makakaramdam din ng ng change in magnetic flux yung loop 1. And therefore, magkakaroon din ng induced EMF dun sa loop 1 natin. Okay, so now, the magnetic flux. So let's note that the magnetic flux is proportional to the current. Diba? Proportional to the current. Kasi, ano yun? Yung magnetic field mo proportional sa current. And therefore, yung magnetic flux mo proportional to the current. Given by, so ito, ano lang siya, equation na sulat natin. So, ang magnetic flux is given by L times I, where the constant of proportionality L is the self-inductance. So, sometimes tinatawag siyang self-inductance. So, lagay lang natin dito, self-inductance. Or sometimes tinatawag din siyang inductance. Ang unit niyan ay henries. Henries or H. Ayan. Yung units ng ating inductance. Class, diba, take natin yung time derivative. So, d phi b over dt equals d dt ng Li. Since ang inductance ay constant lang, try natin kunin yung negative derivative. Class, ang constant constant yung L, pwede nating ilabas dyan. Eh, ano ba ang negative d phi over dt? Diba yan yung induced EMF? So, ang ating induced EMF now equals negative L di over dt. So, kung meron kang changing current dun sa inductor mo, so ang inductor class, let's say solenoid, inductor yon. Pwede ka nang magkaroon ng induced EMF. Diba? Kasi, example, yung alternating currents natin, alternating currents, changing ang current natin. Hindi siya direct current, hindi siya constant. Therefore, magkakaroon ka ng induced EMF. So, kuha tayo ng isang example. So, let's say, an LC circuit. So, inductor capacitor circuit is shown below. So, meron kang, ang inductor class, ganyan yung pangit. Pero, ano lang siya, ganyan yung kanyang symbol sa circuits. Ang capacitor natin, ganito. Tapos meron kang switch. So, yung switch mo, pwede mong i-on or off para maging close or open yung circuit natin. Meron kang inductance L, meron kang capacitance C. Now, if the capacitor is charged up to a voltage V0, so charged up to a voltage V0, and at time t equals 0, the switch is closed. Bali, at time equals 0, magiging active, magiging close na yung circuit natin. So, may current nang dadaloy. Now, the question is, what is the current flowing in the circuit as a function of time? So, as a function of time. Bali, meron kang chinarge mo to at a voltage V0. Tapos, syempre, kapag clinose mo to, magiging ganyan na yan. So, may current kang dadaloy. Pero ang tanong, ano yung current na yon? Since changing siya. Bakit siya changing? Kasi, meron kang inductor dito. Meron kang inductor dyan. So, changing currents, meaning, meron kang, ano ba to? May nasustore na energy dito. And sometimes, gini-give off niya rin yung energy na yon. So ang tanong, ano yung current flowing in the circuit as a function of time? So, let's recall, yung capacitor natin, di ba? Ano ba yon? C equals, Q equals CV. Naalala nyo to sa capacitance. Q equals CV. Eh, yung V yan yung pwede natin yung isulat as the induced EMF, di ba? So, E equals Q over C. Pero ang E natin, recall natin that that is also equal to negative L di over dt. Because negative L di over dt. And take note that, so, and the current is dq over dt, charge per time. So, bali yung ating Q over C, that is equal to negative L d squared Q over dt squared. Kasi ang I mo dq dt. At mag-time derivative ka ulit. At then magiging d squared Q over dt squared. Bali, meron tayong differential equation na d squared Q over dt squared plus 1 over L C Q equals 0. So, class, ano to basic na differential equation lang. Sine, cosine lang to. So, ang ating Q of t, so yan ay A cos omega t or 1 over square root of LC t plus B sine 1 over square root of LC t. Bakit tayo nag-shortcut ng ganito? So, class, tandaan nyo lang, ang d squared x over dt squared, teka nga, Ito, madalas nyo makikita ito. Siguro sa quantum mechanics, makikita nyo to, yung differential equation na to. X double dot plus omega squared x equals 0. So, bali, ang x double dot natin, d squared q dt squared. Ang omega natin, omega squared 1 over LC. So, ang omega, 1 over square root of LC. Ang solusyon nito, a cos omega t plus b sin omega t. Yan na yung ano natin, x of t. So, bali, a cos 1 over square root of LCT plus b sin 1 over square root of LC times t. Paano natin malalaman yung a at b? Siyempre, gagamit tayo ng initial conditions. So, condition 1, at t equals 0, q equals cv naught. So, yan yung ating unang initial condition. So, bali, at t equals 0, cv naught equals a cos 0, so 1, plus b sin 0, 0. Bali, ang a natin equals cv naught. So, let's rewrite, update natin yung ating solution. Q of t equals cv naught times cos 1 over square root of LC times t plus b sin 1 over square root of LC times t. Now, isa pang condition, at t equals 0, syempre, I equals 0. So, 'di ba, nung umpisa, hindi mo pa ino-on yung switch. So, wala ka pang current na dumadaloy doon. Now, paano natin makukuha yung I? Bale, ang dq over dt, yan ay I of t, 'di ba? So, dq of t over dt, I of t. So, bale, ito ay equal sa, this is cv naught. So, negative sign, 1 over L, square root of LC times t, times 1 over square root of LC plus b cos 1 over square root of LC t times 1 over square root of LC. So, yan yung derivative ng Q of t natin. At t equals 0, I equals 0. So, I of 0, so use the initial condition, bali 0 equals CV naught times 0 times 1 over square root of LC plus B cos 0 ay 1 over square root of LC. Bale, B equals 0. Diba? Kasi 0 yan. B equals 0. Therefore, update natin na ang ating I of t, yan ay negative CV naught sin 1 over square root of LC times t times 1 over square root of LC. So, simplify natin. This is I of t now. Yan ay negative V naught square root of C over L. Kasi may C ka dito, may square root of C ka sa baba. Sin ng T over square root of LC. Yan na yung current na flowing sa ating circuit as a function of time. So, kung mapapansin nyo, sin. Bakit siya sin? Kasi yung current class, yung charges natin, sometimes nasustor dito, sometimes nasustor dito. So, parang yung energy class nagaana din, nagaganyan, nagpa-fluctuate. Kaya yung current flowing in the circuit, magpa-fluctuate din siya. Kaya meron siyang sine function siya. Tapos ano yung angular frequency natin? 1 over square root of LC. So, yun yung omega. Kasi sin omega t. Ano yung omega natin? 1 over square root of LC. Okay, so let's move on. Now, for an inductance, sulat ko lang. For an inductance L, and kung meron kang current I, so the work done, or the energy, so the work done is given by, yung energy stored sa ating inductor, 1/2 Li squared. So, kamukha lang siya ng 1/2 CV squared sa capacitor. And the energy stored in the magnetic field, the energy stored in the magnetic field is given by, so sulat lang din natin, 1/2 mu naught integral ng b squared d cube x for the entire space. So, class, di ba dati we have energy stored in electric fields dun sa capacitors natin. Ngayon naman, meron tayong energy stored in the magnetic fields dun sa ating inductors. Now, para saan ba to? Let's take a look at an example. So here, along coaxial cable carries a current I. Tapos, meron tayong with the inner radius A and outer radius B. Bale, meron tayong mga cylindrical shells na coaxial. Ang tanong, find the energy stored in a section of, let's say, length L. Bali, anong itsura nito, class? Meron kang inner cylinder, tapos may current flowing dito na I. Cylindrical shell to, A. Tapos meron kang outer cylinder na may current na ganito. Ang radius naman niya ay B. So, class, i-mental natin, ha? Ampere's law. At S less than A, ang Amperian loop natin ganito. Pero wala kang current enclosed, di ba? Kasi yung current mo nasa surface lang ng cylindrical shell. Bale, B is 0 at S less than A. Now, at S greater than B naman, so kung ang S mo greater than B, ang Amperian loop mo, ito. Ano ang enclosed current mo? Ayan. Bale, may I ka na pa ganito, tapos may I ka na pa ganyan. Ang net nun ay 0. Ang net nun ay 0, class. So, bale, ang Ampere's law mo I enclosed is 0, therefore, B is 0. Now, ang meron lang tayong magnetic field actually dito sa gitna. At between the cylinders. So, bale, yun yung hanapan natin ng magnetic field. So, the magnetic field between the cylinders. So, yan ay B equals, diretsuhin ko na, mu naught I over 2 pi S phi hat. Kasi ang I enclosed mo ay I. So, B times 2 pi S equals mu naught I. And therefore, B equals mu naught I over 2 pi S. Bakit phi hat? Circumferential. Kasi, yung ating current ay diretso lang. Diretso along Z. Diba? So, ito yung Z natin na inikot natin yung cylindrical axis. So, bale, yung cylindrical coordinate system, inikot lang natin. So, phi hat yung kanyang direction. Now, ang ating energy stored in magnetic field is 1/2 mu naught B squared d cube x. So, ang B squared natin, so B dot B, yan ay mu naught squared I squared over 2 pi S. 2 pi S. So, 2 pi squared S squared. Bali, the energy stored now. So, the energy stored is given by 1/2 mu naught integral ng mu naught squared I squared over 2 pi squared S squared d cube x. Pero class, ang d cube x sa cylindrical coordinates ay SDS d phi dz. Bali, ito ay lahat ng constant ilabas ko na. 1 over 2 mu naught squared I squared over 4 pi squared. Tapos integral ng yung s muna. So, meron tayong 1 over s squared SDS A to B. Kasi 'di ba, yung meron lang tayong magnetic field ay from A to B. S equals A to S equals B. Tapos, integral ng d phi. So, 0 to 2 pi. Integral ng dz. So, class, ano yung dz natin? Meron tayong section of length L. So, ang z natin, 0 to L. Ayan. Bali, ito ay, simplify. Yung mu naught, magiging isa na lang. Mu naught I squared over 8 pi squared. Integral ng 1 over s ay ln of s. So, ito magiging ln of b over a. Integral ng d phi, 2 pi. Integral ng dz, L. Bali, ang ating work now equals mu naught I squared L over 4 pi ln of b over a. Ito na yung ating energy stored in a section of length L. Now, let's say, tinanong, ano yung inductance? So, note, work equals also 1/2 Li squared. So, bali, ang ating Li squared ay, yan. So, 1/2 Li squared equals mu naught I squared L over 4 pi ln of b over a. So, kung tinanong, ano yung inductance neto, bali, L equals mu naught L over 2 pi ln of b over a. So, 'di ba, yung ating inductance ay purely geometric quantity lang. Hindi siya dependent sa current or sa charges. Okay, class. So, yan ang para sa ating inductance. Now, let us proceed to Maxwell's equations. Ito yung heart ng Physics 130, yung Maxwell's equations. Okay, so far meron na tayong na-discuss on electrostatics. Meron tayong napag-aralan na rin natin yung magnetostatics. Tapos we also learned about some electrodynamics, yung Faraday's law. Okay, class. So far, we have the following equations. Yung mga pinaka-importanteng equations sa electrodynamics. So, una, meron tayong del dot E equals rho over epsilon naught. This is your Gauss law. Pangalawa naman, we have del dot B equals 0. Ito, class, yung ibig sabihin nito, walang magnetic monopoles. So, ito ay no-name. So, hindi natin alam kung sino yung gumawa niyan. Number 3, ang ating del cross E equals negative partial B partial T. Class, ito ay Faraday's law. Yung sa induced EMF. Tapos, pang-apat, del cross B equals mu naught J. This is the differential form of Ampere's law. Now, pag-aralan natin, class, itong equations na to. So, now let us recall sa vector calculus natin that always the divergence of a curl is 0. Ang divergence ng curl ay 0. Bale, let's say, kunin natin yung divergence ng curl ng some vector function v. Automatic 0 yan. So, I think na-derive natin to from the very first lectures natin. So, now what we'll do is take the divergence of Ampere's law, yung equation 4 natin, i-del dot natin yung both sides. So, meron tayong del dot, del cross B. Yan ay del dot mu naught J. Pero class, ang divergence of a curl is always 0. So, bale 0 equals mu naught del dot J. So, mu naught is constant lang naman. Pwede kong ilabas yan. Pero class, ang del dot J mo, yung continuity equation, negative partial rho partial t. Tapos, 0 lang yan for rho equals constant. Diba class, sa magnetostatics, yung charge density mo along the wire is not changing. That is constant. Therefore, mag-work lang yung del dot J equals 0 kung magnetostatics yung pinag-uusapan natin. That is for steady currents. Bale, ang del dot J equals 0 is only applicable for steady currents or magnetostatics. So, ito ay magnetostatics. Bali ito, magiging 0 equals 0 for magnetostatics only. Bali, equation 4 is okay sa magnetostatics. Pero for changing currents, itong right-hand side, not necessarily 0 na to. So, for changing currents, this is not necessarily 0 for changing currents. Bale, sulat ka natin sa kabila. Now, for changing currents, edi may problema na tayo sa equation 4. Kasi, di ba, hindi siya 0 equals 0. 0 equals some other value na siya. So, we have a problem with equation 4. So, ang ginawa dito ni Maxwell, inayos niya yung Ampere's law. So, how Maxwell fixed Ampere's law? Si James Clerk Maxwell. So, bale, class, recall natin yung continuity equation, del dot J equals negative partial rho partial t. So, di ba, not necessarily 0 yan sa changing currents. Pero class, tignan natin that del dot E equals rho over epsilon naught. So, yung rho natin, epsilon naught del dot E. So, ito ay magiging negative partial t ng epsilon naught del dot E. Bali ito, class, ito ay temporal, partial t. Ito ay spatial, partial x, partial y, partial z. So, bali pwede nating i-interchange yan, class. We have negative del dot epsilon naught partial e partial t. So, yung del at partial t, pwede nating i-interchange yan kasi partial derivatives lang naman yan, mga yan. So, bali ang del dot j natin ganyan. Now, mag-shift tayo. So, now, if we change yung ating current density J, gawin nating J plus epsilon naught partial E partial T. So, saan nanggaling ang epsilon naught partial E partial T? Dito. Bale, class, yung current density J, mag-displace tayo. I-displace natin siya by some value, epsilon naught partial E partial T. Bale, ang equation 4 natin, magiging, so bale, del cross B equals mu naught J plus, eto. So, del cross B equals mu naught J plus mu naught epsilon naught partial E partial T. So, now, i-check nga natin kung yung divergence ng both sides ay magiging consistent. Diba yun yung ginawa natin kanina? Dito nalaman natin na consistent lang siya for magnetostatics. Pero for electrodynamics in general, hindi. So, i-check natin dito. Take the divergence of both sides. So, to obtain del cross B yan ay equal sa mu naught del dot J plus mu naught epsilon naught, ay, teka lang. So, mu naught del dot epsilon naught partial E partial T. Well, yung epsilon naught pwede kong ilabas, pero ligay na muna natin sa loob para mas madali natin masundan. Again, ang divergence of a curl, always zero. So, divergence ng curl, always zero yan. Yan ay equal sa negative mu naught. Ano ang del dot J natin? Negative del dot partial E partial, epsilon naught partial E partial T. So, kaya may negative. Del dot epsilon naught partial E partial T plus mu naught del dot epsilon naught partial E partial T. So, class, always zero ang left-hand side natin. Always zero ba ang right-hand side natin? So, yes, magka-cancel tong dalawa to, di ba? So, 0 equals 0. Okay na. So, parang na-fix na yung ating problem. Kasi di ba kanina, 0 equals 0 only for magnetostatics. Pero dito, 0 equals 0 for all cases. Bale, yun na yung ginawa ni Maxwell. Para ma-fix yung Ampere's law, yung current density, nag-displace lang siya ng some value epsilon naught partial E partial T. So now, update tayo. We have the four Maxwell's equations. Number 1, Gauss law. Del dot E equals rho over epsilon naught. Gauss law. Number 2, yung no-name. Del dot B equals 0. So, yan ay no-name. Ang pangatlo, Faraday's law. Del cross E equals negative partial B partial T. Ang ibig sabihin nito, kung meron kang changing current, changing magnetic field, it will induce an electric field na nagka-curl. So, yan lang yung ibig sabihin ng Faraday's law. When you have a changing magnetic field, it will induce an electric field. And last, yung fixed Ampere's law, del cross B equals mu naught J plus mu naught epsilon naught partial E partial T. Class, ang ibig sabihin naman neto, if you have changing electric fields, it will induce a magnetic field. So, di ba, para lang siyang nag-intertwine lang yung dalawa. Changing magnetic fields induces electric fields. Changing electric fields induces magnetic fields. So, yun yung ibig sabihin ng Ampere's law. Ampere's law with Maxwell's correction. So, class, ito na yung heart ng Physics 130 actually. Ito ang apat na equations na to. Yan yung mga important. Itong Maxwell's equations yung pinaka-important na na-derive natin sa electrodynamics class. So, bale, i-memorize nyo to by heart. So, by heart, dapat kabisado nyo na yan kasi yan yung foundation ng electrodynamics. Actually. Okay, so isulat ko lang. Isulat lang natin na equation 4. So, it states, narinig nyo ba yung mga ibon? Daming ibon dito sa amin eh. At mga aso. So, maingay sila ngayon. So, changing electric fields induces a magnetic field. Ayan. So, class, yung extra term natin na dinagdag, di ba dinisplace natin yung J by some value epsilon naught partial E partial T. Ang tawag dito ay displacement current. So, ang ginawa ni Maxwell, naglagay lang siya ng displacement current. Yung extra term natin yon. So, the extra term, tawagin natin yung JD. Epsilon naught partial E partial T is called the displacement current. Tapos, let's say, kunin natin yung, di ba may fixed Ampere's law tayo? Di ba meron tayong Ampere's law in integral and differential? Meron tayong fixed Ampere's law in differential. Kunin natin yung fixed Ampere's law in integral form. So, bali, when taking the integral form of the new Ampere's law, meron tayong del cross B. Ano tayo, area integral. Del cross B dot dA, yan ay mu naught, bali magiging J dot dA. J dot dA plus mu naught epsilon naught, area integral ng partial E, partial T, dot dA. Bali ito, Stokes theorem, magiging B dot dL na lang yan. Closed loop, B dot dL. Ang J dot dA ay yung current enclosed. So, para ka lang nag-Ampere's law, mu naught I enclosed, pero madadagdagan ka ng extra term. Mu naught epsilon naught, partial E, partial T, dot dA. So, ito na yung ating corrected Ampere's law. So, Ampere's law with Maxwell's correlation. So, this is the corrected Ampere's law integral form. Okay. So, class, I think this lecture will end here. Ito yung pinakamahalaga dito sa lecture na to, ha? Yang apat na equations na yan. So, memorize nyo yan. Memorize nyo yan by heart or kabisaduhin nyo. Kasi, magagamit natin yan sa mga susunod na topics natin. So, itong Maxwell's equations na to actually is the foundation para sa electromagnetic waves, which we will discuss later on. Okay, so I think class, that's it for this lecture. I will see you next time.